Zippity doodah, 4.8. Notice 4.8, we're doing part 2 now. Last time we did adding and subtracting imaginary numbers. Today we're going to do multiplying and dividing imaginary numbers. All right, let's start off with multiplying. Here we have again two numbers. We have a number A and a number B. Remember, it looks like more than one term, but it's actually one solid number. It just has a real part and an imaginary part that goes with it. All right, so let's multiply A times B. What you do is you just substitute in the A and the B. Make sure you put them into parentheses. And then what do you think? What do you think you have to do? Go ahead and FOIL. First, outside, inside, last. There we have it. At this point, there are two terms in the middle that are like terms. They both have i's in it, so go ahead and combine those i's. And then hopefully you remember the definition for I squared. Whenever you have an I squared, remember that is equal to -1. So you're going to replace I squared with a -1, which in turn turns this +20 to a -20. And then the I squared is now gone because it's been replaced by a -1. All right, and then all you got to do is combine these two terms, and then we have our final answer. -23 minus 11i is the final answer. All right. Let's go ahead and do another example. Here we have m times n. Again, throw them in some parentheses. Make sure you FOIL properly. First, outside, inside, last. Again, we have two terms in the middle that you can combine. And then, of course, we have an I squared that you change to a -1. When that happens, we have -10 plus 8i minus 2. Remember, the I squared changes this to a minus. And then the final answer is -12 plus 8i. All right, multiplying, not too bad. Before we do dividing, we're going to need something called the complex conjugate. So basically, the complex conjugate is going to help you divide, but it's basically taking the imaginary part and then changing its sign. So here's an example. I think it's one of the parts on the homework. They give you a number, 5 plus 2i, and then they ask you for the complex conjugate. So all you have to do is take the imaginary part and change it. And that's it. The real part, leave it alone. Change only the imaginary part. And that is called the complex conjugate. Here's another example, -3 plus 7i. And its complex conjugate is -3 minus 7i. What if it's just 6? How do you find the complex conjugate of 6? Well, if you change the imaginary part, it's just 6. And then what if it's just 7i? To get the complex conjugate, it is -7i. All right, so that will help us divide imaginary numbers. So let's go ahead and divide. It says the denominator of a fraction cannot have an imaginary number. So you can't have an imaginary number in the denominator. So let's go ahead and do m divided by n. There it is. 5 plus i divided by -2 plus 2i. So if the denominator has an I in it, then you have to do what's called rationalizing it. So you have to somehow make it so that this I goes away. And the way we do that is we multiply the top and the bottom by the conjugate of the bottom. So if we look at the bottom, the denominator, notice that the complex conjugate would be -2 minus 2i, and that's what we're going to multiply to the top and the bottom. All right, so we took the denominator, found the conjugate, and then multiply it to the top and the bottom. All right, and the reason why we do that, because when you're multiplying, if you multiply with a 1, you're always allowed to multiply with a 1, because anything times 1 just gives itself. So this is just a fancy way of writing 1. So it doesn't change the expression at all. All right, so now we have to FOIL the top and FOIL the bottom. There is the top foiled, and there's the bottom foiled. So it turns out that it turns into 2 multiplication problems. Combine the 2 middle terms. Remember, the I squared is just -1. Same thing. Combine the 2 bottoms. Remember, the I squared is -1. And this is what we have. -10 minus 12i plus 2. And then look at the denominator. The I is gone. And so the whole point of doing multiplying by the conjugate, that purple step, is that it'll always eliminate the I. And that's what we need, is no i's on the bottom. Simplify that a little bit. We get -8 minus 12i. And then here's the thing, is if all 3 numbers are reducible, then you go ahead and reduce all 3 numbers. And there it is. 4 goes into all of them. So the final answer is -2 minus 3i all over 2. Let's do one more just for fun. Here's A and here's B. Go ahead and divide them. There I have 3 minus 4i divided by -1 minus 5i. Again, we're going to multiply the top and the bottom by the conjugate of the bottom. And there it is. Let me erase that little piece. The conjugate of the bottom is -1 plus 5i. Okay, and if we do that, this is what you get. FOIL the top, FOIL the bottom. Combine the middle terms, and then of course the I squared turns into -1. Combine the middle terms, and then of course the I squared is -1. We should have -3 plus 19i plus 20 all over 1 plus 25. And then again, notice there are no more imaginary numbers in the denominator, and it is because of this step. Okay, simplify a little bit, and our final answer is 17 plus 19i all over 26. All right, that is all we have for today. Go ahead and try the homework.